Okay, let's take a look at an example of a math question that at first may look really intimidating. I'm going to be really frank about that. If you take a look at this example here, we see that A is equal to 105. And already the warning signals are coming, are going off in the head, and you're like, that's not an easy number to work with. And then take a look at that next part of the question. A cubed is equal to 21 times 25 times 45 times B. What is the value of B? So wait a minute. A is 105. A cubed, 105 times 105 times 105. So here's the thing that you want to look for in terms of questions that at first look like you're dealing with impossibly big numbers. I mean, even the right side of that equation, 21 times 25 times 45 times B, can look really intimidating. So let's, instead of thinking in terms of like multiplying the numbers out, let's think in terms of the concept of factors. So first we start off by saying, well, we have the number 105. And 105 can be broken up into factors. And this is where we're going to use our skills of prime factorization. 105 can be broken down into two factors, 5 times 21. And you can always just try it with numbers. Like, for instance, if you notice that the number ends with a digit of 5, that means the number is divisible by 5. So 105 divided by 5 will equal 21. But then 21 can be broken down a little bit further. 21 is the same as 7 times 3. So essentially, 105 is the same, or rather 105 is the product of 3 times 5 times 7. Now, taking a look then at that example that we have there, A cubed. Well, anything raised to the third power means you are multiplying that number by itself. But instead of thinking of it as 105 cubed, well, if you say, well, it's really 3 times 5 times 7 that's being cubed, right? Because that 3 times 5 times 7, as we saw before, is equal to 105. So our A cubed in this case, the left side of that equation that we have here, is 3 times 5 times 7 cubed. Now, if you want to expand it out, and you might not necessarily need to do this if you're actually doing the math on your own, but just for the purpose of the illustration here, 3 times 5 times 7 is the same as 3 3s, 3 5s, and, yep, you guessed it, 3 7s. So basically, 105 cubed is the same as 3 times 3 times 3 times 5 times 5 times 5 times 7 times 7 times 7. Now, how does this help us? Take a look at the right side of that equation. 21 times 25 times 45 times B. And how can we break down each of those other numbers? Well, 21, we already saw, was 3, or is 3 times 7. 25 can be broken down as 5 times 5. And 45, at first you may be like, well, it's hard to kind of see what 45 is. So again, just kind of find factors that work. Two factors of 45 that work are 5 and 9. And 9 can be broken down even further to 3 and 3. So great, 45 is the same as 3 times 3 times 5. And of course, the thing that we're solving for, the variable for B. And look at this, folks. It's just a whole mess of 3s, 5s, and 7s. And it's the most fun part of math, right? When you have common factors on both the left side and the right side, what can you do with those common factors? Well, we can get rid of all of those common factors. So for instance, the 3, and the 3 are all going to go goodbye. As well as the 3 5s are going to go away with the 5, 5, and 5 that we see here. And notice on the left side we have 3 7s. On the right side we only have 1 7. So we can cancel out one of those 7s, and then what are we left with? On the left side we just have 7 times 7, and on the right side We just have the variable that we're asked to solve for, and that's b. So our last step here is to say 49 is equal to b, and that leads us to answer choice C as the correct answer. So when you see questions that deal with products of really large numbers, think to yourself, oh, they probably don't want me to multiply this out because anybody can just punch numbers into a calculator. But what are they looking for you to find? They're looking you to see if you understand the concept of factors and multiples and how they can work together with questions.